So with all of these techniques combined, we actually now have the ability to evaluate our special kind of fraction called a difference quotient. And you recall a difference quotient was studied back in chapter 1 when we talked about f of x plus h minus f of x divided by h. Only this time we might be interested to find out what happens to that limit as h approaches 0. So let's try it with a simple function first. Here's our function. F of x equals 5 minus 3x. And we want to find this difference quotient. Now, the one thing that you might have noticed right here is that if you let h go to 0, this is one of those limits that comes out to be 0 over 0 by direct substitution, which means that in most of these cases we're going to have to find some way to reduce and evaluate the simplified expression. So let's talk about this. F of x. What is f of x? F of x is 5 minus 3x in our first example. And f of x plus h means that everywhere we see h in the expression, we replace it with x plus h. 5 minus 3 times the quantity x plus h. So our difference quotient, the one we're taking the limit of this time, is the limit as h approaches 0 of the quantity 5 minus 3 times x minus 3 times h, from right here, minus the original function 5 minus 3x, all divided by h. Now right now, if you substitute in h equals 0, immediately you should see that we're going to get 0 over 0. But that's not what we want to do, so we're going to simplify this a bit. In fact, we will be taking the limit as h approaches 0 of 5 minus 3x minus 3h minus 5 plus 3x, negative of a negative, all divided by h, and certain terms drop out of that numerator. 5 minus 5 as a like term goes away. Negative 3x plus 3x goes away as a like term, and we're left taking the limit as h approaches 0 of negative 3h divided by h. Well, that's a common factor in the numerator denominator, and this now becomes one of our basic rule limits, which is the limit as h approaches 0 of negative 3. Well, the constant, negative 3, will have the same limit regardless of what h does, so our limiting value is negative 3. All right, let's talk about it with this little bit more complicated function. This time we have f of x equals x square root of x minus 2. Well, if we were to put this into our difference quotient, we're going to find the following limit, and that is the limit as h approaches 0 of this quantity square root of x plus h minus 2, right? We replace x with x plus h in this first term, and we're going to be subtracting from that the quantity x minus 2, all of that divided by h. Okay. Once again, it should be clear that if you substitute in h directly right now, you're going to get 0 divided by 0, which is that indeterminate value. Since this involves radicals, we have to take the tactic of multiplying the numerator denominator by the conjugate of the numerator. So in this case, we're going to multiply by the square root of x plus h minus 2 plus the square root of x plus x minus 2. And we're going to put that into the numerator and denominator of the fraction directly. Now, as you know, when you multiply conjugates a minus b times a plus b, it is the same as if you are taking the limit as h approaches 0 in this case of the square of the first term minus the square of the second term. Square root of x plus h minus 2 squared is simply x plus h minus 2 minus the square of this last term. So square root of x minus 2 is x minus 2. All of that divided by h times this whole big quantity right here. Let me move things over. H times our square root expression down there, x plus h minus 2 plus square root of x minus 2 we get rid of our like terms in the numerator, and we're going to reduce that numerator now to h divided by h times the square root of x plus h minus 2 plus the square root of x minus 2. Sure enough, we now have a common factor in the numerator and denominator containing h that cancels, and we're now taking the limit as h approaches 0 of 1 over the square root of x plus h minus 2 plus square root of x minus 2. Doing the substitution, we're going to have 1 over 2 times the square root of x minus 2. I'm not going to rationalize this denominator. I'm perfectly satisfied with this fraction unless we substitute in some value for x that gives us an irrational number. I think this is fine. We'll leave this expression, and this expression is the result of our difference quotient limit.